close your eyes and breathe. In this quiet moment, picture the night sky, not the sky you see above a busy city, but a truly dark sky, far from any lights. It is a vast, velvet canvas, sprinkled with the diamond dust of 1 billion distant suns. For as long as we have looked up, this sky has been our symbol of the infinite, of endless space, of a universe that is forever growing larger, reaching out into the unknown. But what if that was only half the story? What if the endless expansion, the very foundation of modern cosmology, was slowly beginning to falter? What if the universe has begun its long, quiet journey home? Tonight, we will not be startled by this idea. Instead, we will gently explore it. We will drift on the currents of new scientific thought, considering the quiet data that suggests the universe's grandest motion may be changing course. This is a journey into a new cosmic possibility, a story designed not to alarm, but to deepen our sense of wonder as we drift into a peaceful and profound sleep. To understand where we might be going, we must first remember where we have been. For nearly a century, our story of the cosmos has been one of magnificent expansion. It began in the 1920s with an astronomer named Edwin Hubble. Through the lens of his powerful telescope, he observed that the faint, misty patches of light then known as spiral nebulae were not inside our own Milky Way. They were entire galaxies, unimaginably distant islands of stars, just like our own. But he discovered something even more profound. The light from these distant galaxies was stretched, its wavelength shifted toward the red end of the spectrum. He realized this redshift was a cosmic Doppler effect, a sign that these galaxies were not stationary but were racing away from us. And the farther away a galaxy was, the faster it seemed to flee. It was a staggering revelation. The universe was not a static, eternal stage. It was active. It was growing. The fabric of space-time itself was expanding, carrying all the galaxies along with it, like raisins in a rising loaf of bread. This discovery painted the picture of a universe that began in a single, hot, dense point, the Big Bang, and has been expanding and cooling ever since. More recently, in the late 1990s, we found that this expansion wasn't even slowing down as one might expect from gravity's pull. It was accelerating. Astronomers theorized a mysterious, invisible force was responsible, a property of space itself that pushes everything apart. They called it dark energy. This became our standard model, a universe born in fire, expanding forever, driven by a relentless dark energy into an ever colder, darker, and lonelier future. Let us begin our journey by drifting through this familiar, expanding cosmos. Imagine you are looking through Hubble's eyepiece. You are not just seeing light, you are seeing history. Each photon, each tiny particle of light that reaches you, has traveled for millions or even billions of years across the expanding void. You focus on a distant galaxy, a magnificent spiral of pale blue and soft gold. Its light tells a story. The very color you perceive is a message from space-time. As this light journeyed towards you, the space it traveled through was stretching, pulling the light waves apart, making them longer. This is redshift. It is the gentle sigh of a universe growing larger. The light left that galaxy as a vibrant blue or a brilliant white, but after its eon-long journey, it arrives tired, stretched, and red. It is the same reason a siren's pitch drops as it moves away from you. But this is a siren made of starlight, and its song is the song of cosmic expansion. Every direction you look, deeper and deeper into the cosmic ocean, the story is the same. The galaxies are not just hanging in space, they are embedded within it, and the space itself is the active player, the invisible current, carrying everything away from everything else. There is no center to this expansion. It is happening everywhere, all at once. An observer in any other galaxy would see the exact same thing. A universe in majestic, silent flight. This vision of an expanding cosmos is a source of profound tranquility. It speaks of a universe with a history, a direction, a grand, unfolding narrative that began 14 billion years ago. Now, let us turn our senses to another piece of this grand cosmic puzzle. Let us listen, not with our ears, but with our minds, to the faintest and oldest sound in the universe. It is called the cosmic microwave background, or the CMB. Imagine the universe just after its birth. It was not dark and cold, but blindingly bright and unimaginably hot, a dense, glowing fog of plasma. For about 380,000 years, light was trapped within this fog, unable to travel freely. But as the universe expanded, it cooled. Eventually, it cooled enough for atoms to form, and the fog cleared. In that instant, all the light that was trapped was released, and it flooded the cosmos in a brilliant flash. That flash of light is still traveling through space today. But because the universe has been expanding for nearly 14 billion years since that moment, that brilliant light has been stretched, just like the light from distant galaxies. It has been redshifted so profoundly that it is no longer visible light. It is now a faint, gentle, and uniform glow of microwaves coming from every direction in the sky. It is the afterglow of creation. The CMB is a baby picture of the universe, a perfect snapshot of what it looked like in its infancy. By studying the tiny, minuscule variations in its temperature, astronomers can learn everything from the universe's age to its composition. It is the most solid piece of evidence for the Big Bang, a constant, soothing hum that fills all of space, a perpetual reminder of our hot, dense beginning. It is the bedrock upon which our understanding of the expanding universe is built. For many years, the story seemed complete. We had the initial push from the Big Bang, and we had the patient, persistent pull of gravity from all the matter within the cosmos, trying to slow that expansion down. It was a cosmic battle, the outward momentum versus the inward pull. Most astronomers expected that gravity would eventually win, or at least that the expansion would coast, slowing down over trillions of years. But then came the surprise. By observing a special type of exploding star, a supernova, astronomers made a startling discovery. These supernova act as standard candles, objects of a known brightness, allowing us to measure cosmic distances with incredible accuracy. And when they looked at the most distant ones, they found they were dimmer than they should have been. The only explanation was that they were farther away than our models predicted. This meant that in the time it took their light to reach us, the universe had expanded more than we thought. The expansion was not slowing down. It was speeding up. This is where the idea of dark energy was born. It is a placeholder name for a phenomenon we do not understand. We cannot see it. We cannot touch it. but we can see its effect. It acts like a kind of anti-gravity, a gentle, pervasive pressure embedded in the fabric of space itself, pushing everything apart. It is a silent, invisible river that has become the dominant force in the cosmos, its current growing ever stronger, overpowering gravity on the largest scales. Let us visualize this force, this dark energy. Do not picture it as something violent or explosive. Instead, imagine it as the quiet, steady breath of the cosmos. With every passing moment, space itself exhales, gently creating more space between the galaxies. This cosmic breath is faint, almost imperceptible on small scales, like within our own solar system, or even our galaxy, where gravity is still king. But across the vast, empty oceans between galaxy clusters, its cumulative effect is immense and undeniable. It is this force that has been shaping our universe's ultimate destiny for the past 6 billion years or so. It weaves a future that is often called the Big Freeze, or the heat death. It is a lonely, but strangely peaceful scenario. In this future, the accelerating expansion will eventually carry all other galaxies beyond our cosmic horizon. A time will come when, even with the most powerful telescope imaginable, the night sky beyond our local group of galaxies will be completely, utterly empty. The great spirals and brilliant clusters will have been pushed so far away, so fast that their light will never be able to reach us again. The universe will become a place of profound isolation. Stars will eventually burn out. Matter will decay. The cosmos will grow darker, colder, and emptier until it approaches a state of absolute zero and maximum entropy. It is an ending of quiet, cold, and eternal stillness. For a long time, this was considered the most likely fate of everything. A slow, gentle fade into nothingness. But the universe is a place of endless subtlety, and even the most elegant stories can have unexpected turns. In the quiet halls of astronomy, a gentle tension began to build. It was not a loud, dramatic problem, but a persistent, nagging discrepancy in our measurements. It became known as the Hubble tension. In essence, it is a disagreement about exactly how fast the universe is expanding right now. There are two primary ways we try to measure this value, known as the Hubble constant. The first method is to look at the early universe. We use that incredibly detailed baby picture, the cosmic microwave background, and our precise understanding of physics to create a model that predicts how the universe should have evolved over 14 billion years. This model gives us a prediction for what the expansion rate should be today. The second method is to measure the expansion rate directly in the local universe, the one we see around us now. This involves using those standard candles, like Cepheid variable stars and Type 1a supernovae, to build a cosmic distance ladder, measuring the distances and speeds of nearby galaxies. For a long time, these two methods gave answers that were close enough to be considered in agreement. But as our instruments became more powerful, more precise, our measurements became more refined, and the gap between the two answers did not shrink. It grew. It is a small difference in the grand scheme of things, but it is statistically significant. It is not an error. It is a clue, a deep, fundamental clue that our standard model of the cosmos, the story we have been telling ourselves, is missing a crucial piece. To understand this Hubble tension, imagine a beautiful, complex piece of music. The first method, using the cosmic microwave background, is like reading the original composer's score. It tells you the fundamental themes, the intended tempo, the structure of the entire symphony from beginning to end. It is a prediction based on the very first notes of the universe. The second method, using local observations of supernovae, is like listening to the symphony being performed live, right now, in the concert hall. You are measuring the tempo of the orchestra directly in this very moment. The Hubble tension is the discovery that the orchestra is playing slightly faster than the original score indicates. The musicians are not making a mistake. The conductor is not wrong. It means there is something about the acoustics of the hall, or perhaps a hidden passage in the score we never noticed, that is changing the music as it is played. The James Webb Space Telescope, with its incredible power and precision, was hoped to be the final arbiter. Many thought it would find a subtle error in our distance ladder measurements and resolve the tension. But it has done the opposite. It has confirmed the local measurements with even greater certainty. The orchestra is indeed playing faster than the score predicts. This confirmation has turned a quiet tension into a profound and exciting puzzle. The universe is not behaving as expected. Our beautiful symphony has an unexpected movement, and we are just now beginning to hear it. This is where our story takes its turn. This is where we begin to drift from the known into the realm of new, tantalizing possibilities. If our model of the universe is incomplete, where do we look for the missing piece? Many cosmologists are now looking at the one component we understand the least: dark energy. Our standard model assumes that dark energy is a cosmological constant, an unchanging property of space that has a constant density and pressure everywhere and for all time. It is simple, and it is elegant. But what if it is not constant? What if dark energy is dynamic? What if its strength can change over time? This idea is often referred to as quintessence. It imagines dark energy not as a static property, but as a dynamic field, much like an electric or magnetic field that permeates all of space. And like any field, its energy can fluctuate. Perhaps in the early universe, this dark energy field had a different value. Perhaps it was stronger or behaved differently, giving the cosmos an extra push in its youth. This early dark energy could potentially explain why the universe appears to be expanding faster today than our models based on the early universe would predict. It would be like a hidden booster rocket that fired for a short time after the Big Bang and then shut off, leaving a subtle but measurable impact on the cosmic expansion rate that we are only now able to detect. The idea of a dynamic dark energy opens up a universe of new possibilities, far beyond just solving the Hubble tension. If dark energy can change, it doesn't just have to have been stronger in the past. It could also become weaker in the future. Imagine, for a moment, that this mysterious energy field is not a constant push, but a field that is slowly losing its energy, like a battery draining over cosmic eons. If this were the case, the acceleration of the universe would begin to slow down. The cosmic breath would become shallower. The relentless outward push would begin to falter. The eternal expansion would no longer be a certainty. This is where the newest, most speculative data comes into play. Some very recent analyses looking at vast cosmic structures and the way galaxies are distributed, have found faint hints. And it is crucial to remember these are just hints that dark energy might already be weakening. These studies are at the very edge of our current capabilities, and they need much more confirmation. But they have opened a door to a new and awe-inspiring thought. They suggest that the 6 billion-year reign of dark energy, the era of accelerated expansion, might be a temporary phase in the universe's life, not its final state. It suggests that the cosmic tug-of-war between the push of dark energy and the pull of gravity might be about to change winners. Let us float on this idea for a while. Let us imagine a future where dark energy continues to fade. What would this universe look like? The first stage would be a gentle cosmic deceleration. The galaxies at the edge of our observable universe would stop speeding up their retreat. The process of cosmic isolation, the one leading to the big freeze, would halt. No more galaxies would slip beyond our cosmic horizon. The universe would cease its mad dash towards emptiness. Then, as the influence of dark energy continued to wane, the patient, ever-present force of gravity would begin to reassert its dominance on the largest of scales. The expansion of the universe itself would not just stop accelerating. It would begin to slow down. The universe would enter a new phase, a coasting phase, the one that astronomers originally expected to find. The cosmic breath, which had been exhaling for so long, would hold for a moment of perfect cosmic stillness. For an immeasurably long time, the universe might hang in this delicate balance, no longer expanding, but not yet contracting, a quiet, contemplative pause in the grand cosmic symphony. This is a universe with a very different destiny, not one of endless loneliness, but one of potential return. And what if the dark energy field does not just fade to zero? What if it could become negative? What if this quintessence field could evolve to a point where it no longer pushes space apart, but begins to pull it together? In this scenario, dark energy would begin to aid gravity, not oppose it. This is the beginning of the Great Contraction. After that long, quiet pause, the universe would begin a slow, graceful journey in reverse. Space-time itself would begin to shrink. This would not be a chaotic collapse, not at first. It would be an elegant reversal of everything we know. Imagine watching the cosmic movie play backwards, but with incredible slowness and majesty. The galaxies would stop their retreat. And then, over billions upon billions of years, they would begin to approach. The redshift that defined our understanding of the cosmos for a century would gradually lessen. The light from distant galaxies would arrive less and less stretched, its color shifting from tired red back through orange and yellow. The universe would begin to lose its red tint. This is the first, gentle sign of a universe coming home. It is a profound shift in perspective. Our cosmos would no longer be defined by separation, but by reunion. The fundamental motion of everything would be one of convergence. As this great contraction continues, the sky will begin to change in ways we can barely imagine. The light from those approaching galaxies, having shed its redshift, would eventually cross the neutral point and become blueshifted. The light waves arriving from them would be compressed by their approach. their wavelengths shortened, shifting them towards the blue end of the spectrum. The night sky, over unimaginable timescales, would begin to glow with a soft blue light. Galaxies that are today just faint, fuzzy patches in our most powerful telescopes would grow in size and brilliance. The great Andromeda galaxy, which is already on a collision course with our Milky Way due to local gravity, would just be the first of a grand cosmic procession. Imagine a future night sky filled not with tiny points of light, but with the magnificent, sprawling shapes of entire galaxies, their spiral arms and glowing cores clearly visible, a celestial tapestry of breathtaking beauty. The universe would become a much brighter, much more crowded, and much more intimate place. The great voids of space would shrink, and the distances between the islands of stars would diminish. It would be the ultimate cosmic reunion, a slow, inevitable gathering of all the matter and energy that was scattered by the Big Bang. This contracting universe would also grow warmer. The cosmic microwave background, that faint echo of the Big Bang, would experience a blue shift of its own. As the universe contracts, the ancient light waves of the CMB would be compressed, gaining energy. They would shift from microwaves back to infrared, and then, eventually, back into visible light. The very fabric of space would begin to glow. At first, it would be a dim, deep red, as if the universe were lit by a perpetual sunset. But as the contraction continued, that glow would brighten and shift in color, through orange to yellow, and finally to a brilliant, dazzling white. The universe would be returning to the state it was in just after the fog cleared, 380,000 years after the Big Bang. The background temperature of space would rise from the near absolute zero it is today, back up to a gentle warmth, and then to a searing heat. This is not a frightening image when viewed from this peaceful distance. See it instead as a cosmic homecoming. The universe, after a long, cold journey into the darkness, is returning to the warmth and light of its parental hearth. It is the end of a cosmic winter and the beginning of a final, brilliant summer. As the final stages of the Great Contraction approach, the process would accelerate dramatically. The universe would become a place of merging and coalescence. Galaxy clusters would merge, then individual galaxies within them. The sky would be entirely filled with the light of other galaxies, no darkness left between them. Then, as the universe grew smaller still, the stars themselves would begin to merge. The rising background temperature would become so intense that it would begin to strip electrons from atoms, dissolving all matter back into the primordial plasma from which it was born. Planetary systems, stars, nebulae, all the familiar structures of the cosmos would lose their form, their substance given back to the universe as a whole. All matter and energy would be drawn closer and closer together, crushed into an ever smaller volume. This is the journey towards the Big Crunch. It is the mirror image of the Big Bang. Instead of a universe exploding outward from a single point, it is a universe imploding inward. All of its history, all of its complexity, all of its 14 billion years of evolution, collapsing back into a point of infinite temperature and infinite density. It is an end of unimaginable finality. Or is it? Here, at the very edge of physics and imagination, we find the most beautiful and hopeful idea of all, the big bounce. What if the big crunch is not an end? What if that point of infinite density, that singularity, is not a final destination, but a point of transition? Some theories, especially those attempting to unite gravity with quantum mechanics, suggest that as the universe contracts, a new kind of repulsive force would take over at a certain mind-bogglingly high density. This force would halt the collapse and cause the universe to bounce. The unimaginable energy of the collapse would be converted into the explosive energy of a new expansion. In this view, the big crunch would be immediately followed by a new big bang. Our universe would not be a one-time event, but a single cycle in an eternal series of universes. The end of one cosmos would be the birth of the next. It transforms the timeline of existence from a straight line with a beginning and an end into a perfect circle, or perhaps a gentle, rhythmic pulse, a cosmic heartbeat, an expansion, a contraction, a bounce, a cosmic exhale, and a cosmic inhale, forever. In this picture, there is no true beginning and no true end. There is only an endless, graceful cycle of creation and recreation. Let us rest in this idea of a cyclical universe. It is a concept that resonates deeply with many ancient philosophies and spiritual traditions here on Earth. The idea of cycles, of death and rebirth, of seasons changing, is fundamental to our experience of life. To imagine that the universe itself might follow this same timeless pattern can be a source of profound comfort. It suggests a cosmos that is not a cold, random accident heading towards a meaningless heat death, but a living, breathing, and perhaps even learning entity. Each cycle could be slightly different. The laws of physics might subtly change with each bounce. It allows for an infinity of possibilities, an endless cosmic experiment. All the matter and energy that makes up you, me, our planet, and our galaxy would be recycled, reformed, and reborn in the next iteration of the universe. Perhaps not in the same form, but the fundamental essence would persist. The atoms that form your hand might have once been part of a star in a previous universe, and they may one day form a cloud of gas in a universe yet to come. It connects us to a story that is not just 14 billion years old, but one that is truly eternal, stretching infinitely into the past and infinitely into the future. It is a story of ultimate sustainability, of a universe that wastes nothing, a universe that is forever renewing itself. Of course, it is important to remember, as we drift and dream, that this is all a story told by the faintest of clues. The idea of a great contraction and a big bounce is built upon the very frontiers of our knowledge. The hints in the data that dark energy might be fading are tenuous and may disappear with more observation. The physics of what happens in a singularity at the moment of a crunch or a bounce is entirely beyond our current understanding. We are like ancient mariners, just beginning to chart the vast ocean of the cosmos, and we have just noticed a slight, unexpected change in the direction of the current. We do not know if it is a temporary eddy or a fundamental shift in the ocean's flow, but the very possibility is what makes science so wonderful. It reminds us that the universe is under no obligation to conform to our expectations. It is filled with more wonder, more mystery, and more elegance than we can possibly imagine. the Hubble tension, the idea of dynamic dark energy, the possibility of a contracting universe. These are not problems, they are invitations. They are cosmic riddles whispered to us across billions of years, inviting us to look deeper, to question our assumptions, and to continue our peaceful, endless journey of discovery. Let's revisit the changing night sky in this contracting scenario. The blue shift would not just be a scientific curiosity, it would be the most profound transformation of our environment. Right now, space is fundamentally cold and dark, but in a contracting universe, space itself would become a source of energy. As the cosmic microwave background heats up past the boiling point of water and beyond, the very concept of a habitable planet would change. The habitable zone around a star, the narrow band where liquid water can exist, would become irrelevant. Instead, the entire universe would pass through a phase where it has the perfect temperature for life, a habitable era for the cosmos as a whole. It's a strange and beautiful thought. A universe where life might not need a sun because the warmth comes from all directions at once, from the glowing fabric of space-time itself. This period would be fleeting on a cosmic scale, but it could offer a final, brilliant burst of complexity in life before the final crunch. The universe, in its final moments, might become more alive than it has ever been. It is a testament to the endless creativity of the cosmos, finding ways to foster existence even in the face of what seems like an ending. The end of an era is not always an ending of life, but perhaps a transformation into a form we cannot yet comprehend. Consider the force of gravity in this new context. For billions of years, in our current model, gravity has been fighting a losing battle against dark energy on the largest scales. It is the force of connection, of pulling things together, but it has been overwhelmed. In a contracting universe, gravity would have its revenge. It would become the undisputed master of the cosmos once more. The patient, gentle, and relentless pull that forms stars, planets, and galaxies would be the same force that guides the entire universe on its homeward journey. There is a certain poetry to this. The force that governs the fall of an apple and the orbit of the moon would also be the force that orchestrates the grand finale of the cosmos. It would be a final triumph of attraction over repulsion, of coming together over moving apart. You can feel this gentle pull, even now, the force that keeps you grounded, that keeps the Earth in its orbit around the sun. Imagine that same force magnified across all of space, across all of time, slowly and inexorably, gathering all the scattered pieces of creation back into a single, unified whole. It's a vision of ultimate cosmic unity, driven by the most fundamental and familiar force in our lives. What does this new perspective mean for our place in the universe? The story of the big freeze, of eternal expansion, can sometimes feel alienating. It paints a picture of us on a tiny, fragile island in an ocean that is forever expanding, carrying all other islands away from us until we are left in total isolation. It is a grand, but lonely narrative. The story of the Great Contraction, however, changes this feeling entirely. It suggests that we are not being cast out, but are part of a grand return. We are on a vessel that has reached the farthest point of its voyage and has now turned its bow towards home. It suggests that all the distant galaxies we see are not strangers fleeing from us, but long-lost relatives on their own journey back to a common origin. It instills a sense of belonging, not to a small corner of the cosmos, but to the entire cosmic process. It reframes our existence as part of a cycle, a rhythm that is far grander and more ancient than we ever imagined. We are not just spectators of the cosmic drama. We are participants in its eternal, rhythmic dance of expansion and contraction, of birth and rebirth. Think about the journey of light in this new cosmos. In our expanding universe, there is a cosmic horizon, a boundary beyond which we can never see, because the space is expanding so fast that the light from those regions can never reach us. It is a fundamental limit to our knowledge, but in a contracting universe, this horizon would shrink and eventually disappear. As space contracts, light from every corner of the universe would eventually be able to reach every other corner. The entire cosmos would become causally connected. An observer in the far future would, in principle, be able to see the evidence of everything that has ever happened, anywhere in the universe. It would be a state of ultimate information sharing. All the stories, all the histories of every star and every galaxy would be brought together in the final moments. Imagine the universe itself achieving a state of complete self-awareness, where every part of it is in contact with every other part. This is not just a physical collapse, but a collapse of all separation, a merging of all information into a single, unified state. It is a beautiful, if abstract, thought about the ultimate destiny of knowledge and existence in the cosmos. Every photon becomes a messenger in a great, final cosmic conversation. Let us reflect on the nature of scientific discovery itself. This entire conversation, this gentle exploration of a shrinking universe, is a perfect example of how science works. It is not a collection of unchanging facts written in stone. It is a living, breathing process of inquiry. It begins with a beautiful, powerful theory, the standard model of cosmology that explains almost everything we see. But then, with better tools and more patient observation, we find a small loose thread, a tiny anomaly like the Hubble tension, and instead of ignoring it, we pull on it gently. We follow that thread to see where it leads. Sometimes it leads to a dead end, a simple measurement error. But sometimes it leads to a whole new tapestry, a richer and more complex understanding of reality. This process is not driven by panic or crisis, but by curiosity and wonder. It is the quiet, humble admission that we do not have all the answers, and that the universe is likely far more strange and magnificent than our current stories can tell. And there is a deep peace to be found in that humility, in that openness to the immense mystery of it all. It allows us to hold our theories lightly and to be ready to be amazed at any moment. Imagine the astronomers of the far future living in this contracting universe. Their experience of the cosmos would be the complete opposite of ours. For them, every deep space observation would reveal a universe that is becoming more crowded, more vibrant, more energetic. Their version of the Hubble law would be a blueshifted law, where the farther away a galaxy is, the faster it is approaching. Their creation story would not be one of a singular beginning, but of a previous cycle, a universe that came before theirs. They might search for echoes of that prior cosmos, looking for subtle imprints on their own Big Bang. Their eschatology, their study of the end times, would be focused on the physics of the Big Crunch and the potential for the next bounce. Their entire cosmic perspective would be shaped by convergence and reunion, not divergence and separation. It is a fascinating exercise in perspective, reminding us that our own view of the cosmos is shaped by the specific, temporary era in which we happen to live. We are living in the era of expansion, the cosmic afternoon. But there may have been a morning, and there may yet be an evening and a new dawn. Let's consider the nature of time in a bouncing universe. If the cosmos cycles eternally, does our concept of linear time, moving from a fixed past to an unknown future, truly hold? Perhaps a better model is a cyclical one, like the hands of a clock. Each bounce is like the clock striking 12, resetting for the next cycle. This idea challenges our deepest intuitions. Could the arrow of time itself reverse during the contracting phase? Most physicists believe this is unlikely, that entropy and the second law of thermodynamics would still ensure that time flows forward, even as space contracts. But it opens up philosophical questions that are wonderful to ponder as you drift into sleep. Is the universe simply replaying the same events over and over? Or is each cycle a unique improvisation on a cosmic theme? The idea of a big bounce doesn't just reshape our understanding of space. It forces us to reconsider the very nature of time itself. It replaces a finite timeline with an infinite repeating pattern, a rhythm that has no beginning and no end. It is a universe that is not just existing, but perpetually becoming. Now, let us imagine ourselves as cosmic travelers, floating peacefully in the void. In the expanding universe, our journey is one of watching things drift away. We see the lights of distant cosmic cities recede, their colors dimming and reddening until they fade from view. It is a journey into an ever-expanding darkness, a journey of farewells. Now shift your perspective. Imagine you are the same traveler in a contracting universe. Your journey is now one of anticipation. The distant lights are not fading, but growing brighter. The cosmic cities are on their way to you, or you to them. The sky is filling with light, with the promise of arrival. It is a journey of greetings, a universe-wide homecoming. Both journeys are majestic in their own way. But the second one, the journey of contraction, carries with it a feeling of warmth, of community, of a final, inevitable reunion. It is a comforting thought that no matter how far apart things are scattered, there is a fundamental force, a cosmic destiny that will eventually bring them all back together. The universe, in this story, does not abandon its children to the cold and dark, but eventually calls them all back home. Let's think about the building blocks of our universe: dark matter and dark energy. We can only see and understand about 5% of the cosmos, which is ordinary matter. The rest is this mysterious dark sector. Our current mystery, the Hubble tension, and the resulting speculation about a shrinking universe, all stem from our profound ignorance about what 95% of reality is made of. Dark energy, the driver of expansion, makes up nearly 70% of the universe. Dark matter, The invisible gravitational scaffold upon which galaxies are built makes up about 25%. We know them only by their effects. This new cosmological model, where dark energy is dynamic and fading, is really a new hypothesis about the fundamental nature of that dominant 70%. It suggests dark energy is not a static feature of the vacuum, but a living, evolving component of the cosmic ecosystem. It might interact with dark matter in ways we haven't yet imagined. The entire dark sector might be far more complex and interesting than we ever thought. The current puzzles are not a failure of our science, but a direct consequence of us just beginning to probe this vast, invisible, and utterly dominant part of our reality. The solution to the universe's ultimate fate lies hidden in this darkness. As we drift closer to sleep, let us use this cosmic story as a tool for perspective. Think of a worry, a concern that occupies your mind. Now place it in the context of this vast cosmic narrative. Imagine your worry as a tiny speck of dust on a single planet, orbiting a single star in one of 100 billion galaxies. Now watch as that galaxy participates in the grand cosmic expansion, carried on an invisible current for billions of years. Then feel the subtle shift as that current slows and the great cosmic return begins. Imagine your galaxy with your tiny speck of worry inside it, beginning its eon-long journey back towards a cosmic reunion, a final bounce, and a new beginning. In the face of this immense, rhythmic, and eternal process, our own concerns, however immediate they may feel, can find their proper scale. They are part of a much larger, much more resilient story. The universe has been through cycles of unimaginable energy and change, and it persists. This cosmic perspective does not erase our troubles, but it can create a sense of peace and distance, allowing us to release them even for a little while as we surrender to the gentle gravity of sleep. Consider the elegance of symmetry. The idea of a big bounce is, in many ways, an idea about symmetry. It suggests that the universe does not have a privileged moment in time called the beginning. The Big Bang is symmetric with a big crunch. The expanding phase is a mirror image of a contracting phase. This kind of symmetry is something physicists and mathematicians often find in the deepest laws of nature. Beautiful equations often exhibit a kind of balance and elegance. The possibility that the entire history of the cosmos might also exhibit this kind of temporal symmetry is deeply appealing. It suggests a universe that is not a random, one-off event, but one that is governed by a deep, underlying, and beautiful principle of balance. It is like a perfect piece of music that ends on the same note it began, ready to be played again. It hints that the ultimate laws of reality are not just functional, but also, in their own way, artistic and beautiful. And resting in that idea, in the possibility of a perfectly balanced and symmetrical cosmos, it's a wonderfully calming way to end the day. Let's touch upon the silence of space one last time. We often think of space as silent because sound cannot travel in a vacuum. But there is a deeper silence, the silence of immense distance, the silence of galaxies so far away their light is stretched into invisibility, the silence of an ever-emptying future. The contracting universe proposes a different kind of sound, not an audible sound, but a visual one. The approaching blue shift is the universe getting louder, more intense, more present. The brightening sky is a crescendo that builds over billions of years. The final merger is a final, brilliant chord. So as you listen to the quiet of your room tonight, you can imagine two kinds of cosmic silence. The first is the silence of things moving apart, a silence of growing emptiness. The second is the silence of things moving together, a silence of quiet, shared anticipation before a grand reunion. Tonight, you can choose to listen to that second silence, the deep, patient, and hopeful silence of a universe that might, just might, be on its way back home. It is a silence filled not with loneliness, but with the promise of convergence. Finally, let this entire journey be a metaphor for your own breath. The story of the Big Bang and the eternal expansion is the long, slow exhale, a release of energy, a movement outward, a scattering into the world. It is the active part of the day, the journey out into the vastness of experience. The story of the Great Contraction is the long, slow inhale, a gathering of energy, a movement inward, a return to the center. It is the quiet of the evening, the journey home to a place of rest and unity. And the big bounce? That is the quiet, still point between the inhale and the exhale, the moment of perfect peace and potential, where one cycle ends and the next is about to begin. As you lie here, ready for sleep, feel your own breath mirroring this cosmic pattern. The gentle exhale, letting go of the day. The gentle inhale, drawing in peace and quiet, and the still, calm moments in between. You are not just in the universe is in you. Its most fundamental rhythms are your rhythms. And by aligning with this simple cosmic pulse, you can find your way to a deep, restorative, and peaceful rest. So, we find ourselves at the end of our journey tonight, floating in a sea of new possibilities. We started with the comfortable, familiar story of an ever-expanding universe, destined for a cold, quiet end. But by following the faintest of clues, the subtle discord in the cosmic symphony, we have arrived at a new and profound vision. A vision of a universe that might not be dying, but might simply be breathing. A cosmos where the endless expansion could be just one phase, the great cosmic exhale, that may be followed by a long, gentle inhale, the great contraction. We've imagined a future sky filled with the brilliant blue light of approaching galaxies, a universe warming itself for a grand reunion. And we have contemplated the most beautiful possibility of all, the big bounce, which transforms the story of our universe from a linear tale into an eternal, cyclical poem. This is the true wonder of cosmology. It shows us a universe that is constantly revealing itself to be more mysterious, more elegant, and more surprising than we ever dared to dream. The certainty of today can become the beautiful question of tomorrow. And resting within that question, within that boundless sense of wonder, is a perfect place to find peace. Thank you for joining me on this quiet journey through space and time. If you found this cosmic story relaxing, please consider subscribing for more journeys into the quiet wonders of the universe. Like this video to help others find a moment of calm. And please, share your thoughts in the comments below. Does the idea of a cyclical, eternal universe bring you comfort? Until next time, I wish you sweet dreams and clear skies.